This is the Amp Hour Podcast, released November 13th, 2022, episode 609, Open Circuits with Eric Schlaepfer and Windell Oskay. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, I'm Windell Oskay. I'm the co-founder of Evil Mad Scientist Laboratories, and my background is in atomic physics, and now I make pen plotters. Recently co-wrote with Eric Schlaepfer the book Open Circuits.
Hi, I'm Eric Schlaepfer. I'm also known as TubeTime on Twitter, and I co-authored the book with Windell.
All right, welcome, guys. I'm very excited to talk about this book. We've been talking about it on the show many times. We got some copies. Thank you for that. Pitching those our way. And boy, oh boy, I'm going to say this many times throughout the show. This is a gorgeous book and lots of beautiful, beautiful photos. So thank you for making this. Yeah,
thank you.
It's already a joy just peeking through it. So yeah, so Windell kind of got into some of his background, but let's get a quick background on both of you. So Windell, you were at NIST, if I remember correctly. Is that right?
Yeah, I did a postdoc at NIST after grad school, and I spent 3 years there working on atomic clocks. I actually worked on a single ion optical clock where I trapped a single mercury ion. We probed it and made some very precise time measurements.
Oh, that's cool.
Worked on some of the most precise lasers in the world and got to learn a lot of stuff.
Very cool. Very cool. And obviously, Evil Mad Scientist is, we've talked about your blog many times in the show before and all of the various projects you make. Is it emsl.org? Is that right?
It's actually evilmadscientist.com, a very long domain name.
Got it. Okay, well, it's available. That's great. Yeah. Okay, well, we'll poke through there too as well, and we can kind of refer back to things. Eric, what about you? What's your background?
I've been involved in electronics for a really long time. There's actually 8mm film footage of me as a 4-year-old making a complete circuit with a battery and a light bulb and some wire. And I actually got into software for a little bit, ended up getting a degree in electrical engineering, and then pursued a career in the semiconductor industry for a while, and eventually wound up at one of the big tech companies doing hardware design.
Cool. If you have hipster parents, you could still make a 8mm film of completing a circuit in modern day.
Oh, this was non-ironic 8mm film.
It's just because of what was there. Yeah.
Yeah, exactly.
Nowadays, Eric makes open circuits.
Yeah. Are you doing like the open silicon stuff or something else?
No, what I typically do is design things like clones of old retro sound cards or other things that people like to use in retro computing. And I tend to release those as open source hardware. I've always felt that my time is better spent doing things that I enjoy, like designing circuits, rather than managing sales and shipping and all the rest of the things that go with trying to sell hardware. And so the idea behind open source circuits, at least for me, is that I can do the stuff that I enjoy and then allow other people to get those designs for free and use them however they want. So they can go and manufacture their own boards and sell them to their friends, or they could go on eBay and sell them that way.
That's great. Yeah, Windell talked about really precise time and like measuring really precise time. And it was about precisely 20 seconds for me to get that he was actually talking. That was a callback to the book name. And so that was a good one, Windell. Sorry. It's a little late here. I'm a little, it's been a long day here.
We both do a lot of open source stuff as well. So perfectly
that's
fine
right.
Call out.
Yeah. Okay. That's cool. Yeah. And so you guys, I remember one of the things when I remember seeing you, you've been collaborating for a while, but one of them was it Open MOS? What was that huge circuit board?
Well, there was one before that, actually two before that,
okay.
that we should probably mention first.
Sure, yeah, let's get them all in here.
Yeah, that was the collaboration on the 3.5's discrete 555 timer kit, which is a real product that you can buy at EMSL.
I do the selling of the hardware, which is this terrible thing that Eric was describing. It is indeed terrible.
Exactly. And I really appreciate the hard work.
I hate my UPS guy.
No, we love the UPS guy.
I know.
The courier is like, they make business possible. I'm so happy with them.
It's true.
Yeah, exactly. And it turns out, so the 555 timer is not a very complicated circuit internally. And even when I was younger, you could open up a data book and they would actually show you what the internal schematic was. They would show you all the transistors. And I always thought it'd be fun to try and actually build one out of transistors to see if it would work. And I did. In fact, that prototype is on display also at EMSL. So I think, Windell, you have that in your cabinet.
Yep.
And then we decided to turn that into a kit. And so you can go and buy this kit. It comes with all the components you need and solder together your own 555 timer.
Yeah, I believe we featured this when it first came out as well, because I remember specifically the screw terminal, like things that made the bent metal legs go on, or I don't know if they're even metal, if they're plastic or metal. What is the material there?
The first version of the kit, we actually had a formed PVC foam legs, and they were gray.
Oh.
And then we revised the kit a year or so later with aluminum sheet metal formed legs that really just looked the part so perfectly.
Yeah, they look really good.
Yeah, just to describe it for people, I mean, so it's a black circuit board, but it's definitely like a blown up version, and you've got all the N channel and P channel FETs, or sorry, P channel.
Yeah, so the original prototype that Eric made is this gorgeous piece of circuit artwork. There's no circuit board per se. There is literally a wooden board with little terminals hammered into it, and the individual transistors and resistors are soldered to these little hammered in terminals, and there's little banana plug jacks on the sides. So it's this wonderful piece of wooden artwork. And the genesis of this kit actually was that I had brought a giant wooden 555 model that I had made out of wood, CNC routed wood. And he had brought this model. We set the two things next to each other, these two gigantic inflated 555s, one physical, one electric. And we realized, we should do this thing right.
Yeah.
So we collaborated.
And the one you made, the wood one, was a footstool? Is that when I remember
That's right? It's just a footstool, a piece of
Yeah.
silly giant furniture. So we collaborated on designing a circuit board that would be the right shape to visually look like a dip chip 555. And I ended up giving Eric a outline, said, make it look like this. And he designed the circuit and made it work there. And we designed a kit around it so that you can solder it yourself, and it's easy and fun to build.
Yeah, I think there's a photo of that prototype around somewhere, maybe on EMSL. I forget if we took a picture of it for the website. You could certainly find it on Twitter if you search around my Twitter account. For those listening, it actually looks a lot like the circuit art that Jim Williams used to construct back in the day.
Yeah, that's great. That's great. And it, like you said, there was like nails in the board as well, like a true. The term breadboard came from that space, right? Where it was actually like a piece of wood people were cutting bread on, and then they hammered nails into it, that sort of thing, right?
Yeah, little terminals. So with a little ceramic base and a cute little terminal on it.
Cool.
It's art basically.
Yeah, that's great. That's cool that it's still around too. That's a good showpiece to have in the cabinet.
So that was the thing that kind of started it all, and naturally we started thinking about some other chips that are very well known and well loved by the community, and kind of the other obvious choice was the 741, because that's the op amp that everybody gets started with. And it turns out that's not very complicated either. Again, it's maybe 24 transistors and that's it. And so that was kind of our next collaboration. It fits very neatly in the series. And then, of course, we decided to build a surface mount version so that people could use that as a way to practice surface mount soldering. And naturally, we also had to change the legs so that instead of looking like those through-hole dip pins, there are those little gull wing surface mount leads on it. So it definitely looks the part.
That's great.
So we've made both of these in SOIC packages, so to speak, that are matched exactly in scale to the dip counterparts with half the lead spacing and so forth. And they have these little tiny screw terminals that you can use to attach your wires to them.
Oh, yeah, because they're actually operational, of course.
Oh, yeah.
That's great. That's great. Yeah, and I mean, the fact that it is surface mount, you could practice as well. That's really cool. Have you seen them being used kind of out in the world as like educational pieces or just kind of show pieces? Where do you see them actually being used?
We do actually see quite a lot of sales to community colleges where people are getting a whole set of them. We've also seen classes where it was obvious that somebody told all of their students to buy one because we suddenly got 40 orders from San Diego to individuals. So
yeah, right.
There's definitely some use of it. It's not that every college is using it, but there certainly are a few out there.
Yeah.
One of the nice things about the kit is that it makes it possible to make modifications to the circuit and to hook an oscilloscope to internal nodes and kind of explore just how the chip actually works, which is really neat.
Yep. Yep. This, yeah, it's railing because of the bad setup that I did on the outside, but now we can see what happens on the inside.
Exactly.
Yeah, and if
Yeah,
your setup
that's
on the outside is bad enough to blow out a transistor, well, you can go in and fix it.
That's true. Yeah, that's nice too. I didn't thought about that. And it's, I mean, it's crazy. Just, I mean, even just to have that conversation with someone. I remember the first time I used an op amp. Well, the first time I saw an op amp was on a page as a triangle, right? That's probably the most confusing way to get introduced to one. But like, but then you actually see it, and you're like, oh, okay, it's like a real thing. It's not very triangular. I don't know where that came from, but I get it now. There's a thing here. But then it just, yeah. I mean, the actual telling me that it's full of transistors and there's all this stuff here. I feel like it's presented in such an abstract way that to get down into the actual fact that there's transistors, operating there is very important from a kind of piecing it all together.
Yeah, definitely. If anything, when they start teaching it, they typically start with the ideal op amp, which isn't really the best place to start. So
No,
it is
it's
a model, but it's
confusing.
a little bit of a confusing model. Yeah. So if you start with the model where you're just simply taking the difference between the two input voltages and then multiplying that by a gain, that's way easier to understand.
Yeah, I agree. I think it's done because the professors want to be able to teach math and KVL, KCL right away and that sort of thing. I think it's used in the purpose for that. And yeah, it's a rough introduction. I went on to work with top amps a lot later, and I was like, oh my god, 3 years later, I'm like, yeah, I start to get this now.
Yeah, you can definitely get into trouble with ideal op amps. As a
Oh my
joke, one
gosh.
time I put together a fake data sheet for an ideal op amp
Hmm.
and spread that around on Twitter for a while. But it's one of those things where you read all the specifications and you just realize how horribly contrived the ideal op amp is and just all the different unrealistic properties of it.
I had a college class where the professor told us to measure 20 properties of an op amp, which included, input, offset voltage, and all those things, and didn't give us any clue what those things meant or how to measure them. And it was just sort of one of the most
Boy.
horrible days of my life, and
Oh,
learning how to do electronics.
yeah, that's rough too because it's like you know, it's something that really matters quite a bit, but it's just without context there, like like where do you even start?
And that was the first day that Horowitz and Hill saved my life.
No, yeah, there you go. There's the title of the episode right there. That's great. Yeah. Well, I was thinking about is it OpenMOS? Is that the name of the big processor thing?
You're thinking of the Monster 6502.
Monster, that's it. I was thinking about that recently because the SuperCon badge had the similar kind of like light up, blinky nature with all of the processing, with all the the various stages of a processor passing through it. That was a 4-bit computer that on the SuperCon badge. What was the Monster 6502?
Yeah, so that was a really interesting project. It kind of started out oddly enough with the 555 timer kit. And Windell, you could probably fill me in on the details because it's a little fuzzy for me, but there was an event. I think it was either a Bring a Hack dinner or a Maker Faire after party type of event. And
It was the after party at BJ's after Maker Faire. Bunny was
Oh
there.
man.
He was having a good night.
and
Oh
that
yeah.
was the one that Jerry Ellsworth had set up. Yeah, I remember
Hmm.
that.
Yeah. Do you know that is actually the basis? That specific event. That was the basis for starting SuperCon because
Really?
yeah,
Huh.
well, so like so I was working at Supply Frame at the time and got to hang out with all the Hackaday folks, and like we would all go to that event, which was after Maker Faire, and so it was like Sophie and myself and Alec, our boss, and Mike Stish, and we all were like sitting, oh, and Matt Bergman as well, and we were all sitting around, and we're like, all I really care about is that party after Maker Faire. What if an entire conference was that party after Maker Faire? And that's like literally that is the thesis statement for SuperCon,
Ha.
and I think it delivers. Honestly, it was that's all. That's why I just want that every day of the year, right? Every meetup I do, every conference I go to, I want it to be that experience at BJ's after Maker Faire.
Yeah,
That was
exactly.
the basis.
It
So
was just fantastic, and there was just so many smart and creative people, and so much communication going on, lots of ideas and things like that floating around. And so we had this little thing with us, and somebody came up and made a not really a sarcastic comment, but like a little bit like a challenge, like, "Oh, that's cool, but could you do an entire processor that way?"
oh man, you don't even remember who it was, or you do?
It was Bunny.
Was it Bunny?
It was Bunny. Oh man,
Of
that
course.
guy,
And
troublemaker,
he was
troublemaker.
he was off the cuff estimating how much surface area he said, and he said probably be about the
Ah,
size of that table right there, pointing at one of those tall cocktail
like a high,
tables.
high top. Yeah, yeah.
Yeah, and
Yeah, he's
he
not too
wasn't
far
that
off. I
far
mean,
off.
yeah, order of magnitude at least. You know.
Yeah.
Yeah, a little bit smaller than that. I think we did some of our own Fermi estimation to kind of figure out ballpark what it would be.
Mm.
And that was kind of when I started considering the 6502 as a candidate for the processor. So for people who don't know what that is, it's an early 8-bit microprocessor. It came out in the mid 70s, and it rests at the heart of a lot of classic 8-bit computers from that era, from the 70s and the 80s. And so things like the Apple I, the Apple II, Commodore 64, Nintendo Entertainment System, at their heart, they all have this 6502 processor.
Yeah, keen listeners and rememberers will remember we had Chuck Peddle, who's unfortunately passed away. He was on the show back in episode 241, so that was 2015. So I'll link that in as well. But Chuck was amazing.
We should say explicitly, Chuck was the designer of the 6502.
Yes, sorry. Thank you. That's very clear there. We were introduced from Bill Hurd, who had used to work with him at MOS or MOS. What do you say there?
MOS.
Yeah. Okay.
Yeah, so it's MOS. It's a really interesting design, and I hadn't really gotten familiar with it before the challenge, I guess you could call it. And the reason that I picked it is because it had the lowest transistor count of any common popular 8-bit microprocessor that I could find. And I didn't know how it worked. In fact, I did not even know 6502 assembly language. So I had exposure to computers that used it, but I had only programmed them in BASIC.
Got it. Yeah. And most people were operating at the assembly level when it came out, of course, right? I mean, they weren't, BASIC wasn't a thing till later.
Yeah, when it first came out, BASIC came along very quickly because BASICs had existed on other architectures, and those quickly got ported over to the 6502.
Cool. Yeah. Well, I'm looking at the specs on the monster6502.com, which has its own site. Very nice. Total part count, 4769. Holy moly. That's a lot of picking and placing.
It really is.
It's a good thing I don't do that by hand.
Yeah. I mean, it's a full-size panel that's on this board. I mean, this board was basically a full-size panel.
It's not quite a full-size panel. It is large, but it doesn't quite fill the full panel.
It is the only thing that gets to run on that panel, though.
Yeah.
Right. Yeah, definitely.
Yeah. Wow. That is really cool. Yeah. What else can we say about it? I mean, well, the LEDs. So the LEDs were a add-on just to make it more visible. Is that right?
No, those are on the original MOS 6502. You just can't see them because of the black plastic dip 40.
Oh, that's right. Yeah. You got to get the special epoxy version in order to get it.
Right. Yeah, something like that. Now, I put a bunch of the idea behind the LEDs was to be able to view everything that maintains a state, and so that includes all the registers, all the register bits, a bunch of internal latches, things that contain the instruction register, timing state machines. All of that comes out to LEDs. So by single stepping through code, you could actually see the entire processor state at every step.
It's a LED bugger.
That's right.
Nice.
Did you just come up with that?
I regret that I did, yes.
So I am, scrolling. I must have come upon the site in the past, but this is implying that you're going to make this available to the public. Is that correct?
It is, but we are really hamstrung by the chip availability crisis.
Got it.
And one of the things to know is that a 6502, it's just a CPU. If you actually want it to do anything, including just run some blinky lights to show that it's alive, you're going to have to put that into a computer. So Eric designed a wonderful tiny computer that we hide in that picture frame that you can see on the Monster 6502 site. It's in the back, and it emulates the entire rest of the computer: the RAM, the ROM, the clock, input, output, all the things you need. But it's a STM32 that's running that, and that seemed like a great idea in 2016, 2017 when we were gearing up on this project. And now it's just like, are we really gonna
port it to the RP 2040 or something?
We're just kind of dragging our heels and hoping that there will be some signs of clear skies that will say, go ahead. This project isn't time critical. in a sense. It is critical that it is done really well when we go whole hog with it, because it is very expensive.
Yeah, definitely.
Yeah. And I mean, this is meant as a showpiece, right? That's kind of the idea.
Oh, absolutely. In fact, Windell, you put together essentially a museum quality shadow box frame for it.
Yeah.
Anti-reflection glass.
Ah, very important. Yep.
Yeah, this is something that you could hang up on your wall, and everyone that comes into your office is going to see that and have their mind blown for a while.
Yeah, definitely. Yeah, that's cool. I mean, you could go to a ESP32 and then make it Wi-Fi connected as well. You could pass new programs to it or something.
Yeah, I mean, there's a couple of different options we're looking at. I did look at the RP2040, but unfortunately, it doesn't have quite enough I/O pins to control it.
Got it. Well, that thing is beautiful. I got to see it at Maker Faire. You guys were actually running demos. I think you were running it as a computer, right? You had it plugged into a bunch of other stuff that made it possible.
Yeah, that's right.
That's cool. Yeah. Yeah, it is amazing how the 6502 kind of just was so influential in the industry. And it's, I mean, how old is it now? Is it in the 50 years old?
It came out in 1975.
Okay. So we're getting there. We're getting there.
Yeah.
Damn. Crazy. Well, that's really cool. There is a sign up at the bottom of that page as well if you want to get notified when it's available. So I would recommend enthusiasts do that sort of thing. All right. Well, speaking of enthusiasts, let's get to the main event here and talk about this book, because I am an enthusiast, and everyone I see talking about it on Twitter or otherwise is also an enthusiast. First off, what is the thesis statement for the book?
I would say that the thesis statement for Open Circuits is there is gorgeous design inside of your electronics, and you just haven't seen it yet.
All right, yeah, that's good. Just gotta cut things in half, or wait until Eric and Windell do it. So, so let's talk a little process then. How the heck did you cut all these things in half and get them to the point where they are? So, if people don't know, this is basically showcasing the guts, like Windell sort of said, and you guys actually have the photos of like a lot of cross sections, it seems like, but it seems like that would not be, that is a non-trivial thing to do, to get those cross sections.
It is much easier than you might guess.
Really?
The vast majority of those samples were cross-sectioned using ordinary hardware store sandpaper.
Oh, interesting.
Easy is relative.
Okay.
Technically
Tedious,
easy.
yes.
Technically easy, but this sort of crosses the line past the amount of work that something requires to the point that you must call it art, because there's no other possible justification for it.
Got it. I mean, so like, I guess we should also go to the book site here as well, which is opencircuitsbook.com. You can follow along and purchase your copy there. But there's some example photos that we'll be referencing here. So the first photo in the gallery is a 3.5 millimeter jack, and it shows like the gold and the blue and, basically the cross section of that. That was just sandpaper or bandsaw and sandpaper?
There's actually two different techniques here. There's a 3.5 millimeter plug, and there's a 3.5 millimeter jack, and they were actually done separately. The 3.5 millimeter jack was cut by Eric, I believe, just using sandpaper and great amounts of patience.
Well, we did some experiments with that. The jack we also attempted on the mill.
This jack was, I believe, cut on the mill. There's actually a picture in the back of the book on the section on how we made the book showing how this very jack was cut.
Okay, good. So that's a good.
Yeah, the
good
plug was sandpaper though. That was just me and a sheet of sandpaper and a little water, isopropyl alcohol, and a lot of time.
Yeah, couple of Bob's Burgers episodes and Bob's your uncle.
Yeah, pretty much.
That was my go-to layout show. I was doing layout and just had Bob out in the corner, just talking about burgers.
I usually put on podcasts and stuff, so typically I'll
listen to them. Never listen to them myself.
So it was you, Chris. You made this cross section.
Oh, I made it possible. Oh,
actually, I think at the time I was listening to Embedded.fm. So,
well, that's a good one too. And you guys have been on Embedded, I know, yeah, Enemy Podcast. You guys have also been on that show. We should refer to that, and people can go and hear you guys on that show. They got to you first.
They did, and they asked orthogonal questions, so don't worry about it.
Oh, great. I'm sure I will duplicate some stuff. I did listen to it, but it was a while ago. So, like, what else could people expect in the book generally? Like, is it classified by type of electronics? Is it classified by, how is it laid out? How did you want to kind of walk people through electronics as a viewing medium?
So this is really a survey across all of electronic components, not really all of electronics. So we don't show you, for example, what the inside of different types of radios and food processors looks like, or washing machines, or different types of other appliances and electronics. But it's really trying to showcase different types of electronic components. And we organized it by what an engineer would typically call most of these components. We have a section of passive components, a section of semiconductors, a section of cables and connectors. We also have a retro tech section that is primarily obsolete things, which we started out with an incandescent light bulb sort of as a joke. And we have a section of composite devices, which was sort of a catch all for components that have other components in them, but also circuit boards. And at the end, there's a section about the making of the book.
Cool.
I hope I didn't miss
great.
any. Oh, yes, I did miss one. There's a section on electromechanics, which is switches and motors and things.
Yeah, we tried a bunch of different ways to organize the book, and this one really felt right. Everything kind of gelled.
Yeah, that's great. That's, I mean, thinking through like how I think about components and stuff like that too, it does kind of line up with a lot of that sort of thing. So the retro tech is also like stuff that I didn't really think about, like so like neon lamps are one thing where I've never actually designed with them, so I wouldn't think what's inside of those sort of things.
That's sort of a remarkable example because it is such old technology. It is literally a vacuum tube, and yet they're still built into so many things that are manufactured now, like light switches for your house that glow just when they're energized, or extension cords that have a light in them are all neon bulbs.
I'm sure some listeners are shouting right now, "It's not a vacuum; it's filled with neon."
Ah.
That's a good point. That's a good point. Yeah, it's interesting as well because I just actually finished Kathy's book. I forget Kathy's last name. Shoot, she was just on with Dave a couple weeks ago, and about the history of electricity. And so I've been actually going back through and reading about all of the historical how things were built and designed and discovered and stuff like that. And especially in the retro section, like really all of these things, it was just been so completely mind blowing as people were building these things up, and now it's just stuff that it's all around us, and it is so prevalent that we just forget about it all the time.
One thing that really struck me when we're doing research for the book is that the old style of components, not just stuff in retro tech, but stuff that's even older than that, they're made using very natural materials. Lots of brass and wood and some very early plastics and things of that nature. And nowadays, everything is synthetic. So it's some variety of plastic with some fiberglass, and it's a much longer supply chain, if you will. So there's a much longer distance between that finished good and the raw materials that went into it.
What did we have that had wood in it? I don't remember.
Yeah.
Well, we had some early plastic, and I think it was the capacitor that I think might have had like
Bakelite
sawdust or
style.
something like that in it. Yeah, kind of Bakelite style.
Mm.
Phenolic, of course, is kind of a impregnated paper. So I think we had one
that's like
phenolic
the
circuit board in there.
Phenolic's like the one that you see in like really low cost, like single sided designs, right? Like in the power supplies of
It's really cheap.
like a TV.
Mm-hmm.
It's a funny word because phenolic used to mean just plastics that were made with phenol resins, things like Bakelite and so on. But the term phenolic really does include every FR4 technically as it's used. That every type of composites that are of a certain class are all regarded as phenolics.
Mm-hmm.
But it's
interesting.
Such different meanings of the term.
Yeah. Speaking of FR4, when you were kind of getting into some of these things, I mean, were there concerns about just breaking stuff apart, like like fiberglass and just being in the air, that sort of thing?
Yeah, in general, you want to avoid getting fiberglass dust into the air. So it's just really not good for you. And so typically sanding, you want to wet sand. Make sure you've got good ventilation and all of that. Another good one is that when you're done, you don't want to dry wipe any of the surfaces because that'll generate dust. And so you go in with wet wipes to make sure that's all kind of cut down. So it's one of the it's one of the reasons why I recommend that people actually don't try some of this stuff at home unless they understand all of the PPE that they need to do it safely.
Yeah, that's a good point.
And some of them, things like Nixie tubes, there's mercury in those. You really are going to come across nasty stuff if it just takes stuff apart randomly. You need to be aware of it.
Yeah, definitely. And in fact, some other components like certain kinds of power transistors use beryllium oxide in their construction, and that is quite hazardous to cut into.
Okay. Mm.
So that does require some specific knowledge about what has that stuff and what doesn't have that stuff. And so there were definitely items on our list that we looked at and said, you know what, this is not really safe to cross section, so we'll just
Yeah.
skip that.
Yep.
Yeah. I mean, did you guys have to, was it generic enough stuff that you were just kind of sourcing it from around the lab, or did you have to kind of hit up the rapidly shrinking surplus stores of the Bay Area?
A lot of the stuff is from our personal collections, and a lot of it is from the surplus stores. Some stuff we got on eBay specifically for the project. If we know that the book was going to do so well, we might have spent a little more on getting some esoteric components from online sources.
Oh, like, did you leave stuff out specifically because of cost or just struggle or whatever?
It's a funny thing. Not every sample that you get your hands on is going to turn out to be a good photograph or a good subject to describe. And so some of the parts that Eric put an immense amount of work into preparing, we just ended up not using because we couldn't get a good enough photo of it. It just wasn't going to be photogenic enough. And we can buy some exotic chips online, but if you don't really have great confidence in it, it's a little harder to go out and do that.
Yeah, there's always the risk that you spend a bunch of money to buy something, and then you go and you cut it in half and look at it, and it's not very interesting. Yeah.
Poor little component. It was sacrificed for nothing.
For a good cause.
Yeah, that's true. I have to say, this book, even though the style is very different, right? This has a lot of bright colors, and obviously it's cross sections and stuff like that. I can't help thinking about the way things work. Like that is a formative book in my past. I would just sit there reading it and rereading it over and over again. And I have to imagine a young person getting this sort of thing is just going to be like marveling at this.
Yeah, I think that's right. In fact, I've heard the same thing from a number of other people. The way things work actually really impressed me when I was a kid too. That was definitely one of my go-to books growing up, along with a much more obscure book with sort of a similar style, I guess, but far more technical. So they had technical drawings instead of the sort of cutesy pencil sketching. And it was apparently made by a German publisher and translated in English. I wish I could go and look it up for you, but I don't remember what it was called offhand.
Okay, well maybe we'll find out later. If so, I'll put it in. But yeah, I mean, if it doesn't have little mastodons like pulling the CD drive, I don't know if it's really going to work for me.
Those are so great.
You guys should have snuck at least one or two into your little Easter eggs or something here, right? Surely there's one hiding in your photos.
We have a few subtle phrasings that could probably be classified as jokes, and there's one illustration that you might find that could be properly classified as a joke as well. We didn't go quite as far as the mastodons, though.
Got it. Okay. All right.
And I think there's also a little secret hidden in the end sheets, but you'll just have to get the book.
Oh,
and
yes,
take a look.
there is indeed.
Yeah, I guess so. Yes, I mean, in all things here, obviously, no matter how well we try and describe these things, I don't think we're gonna possibly do it justice.
I was going to say, amazingly enough, if you view the pictures on the web, they're going to look great, right? So you can go to the opencircuitsbook.com and see some samples. Those pictures don't really do the book justice, because if you have the book in your hands and you open it up and you look at the picture, it just looks 10 times better than what you see on the screen.
Yeah. Yep. Yeah. I mean, and it is like like we were talking about before the show. You said this is meant, much like the way things work, this is meant as a coffee table book. Kind of sit out, leaf through it, discover new things.
Yeah, exactly.
That's great. What surprised you? What surprised you as you were kind of discovering the inside of the guts of these things?
Every day was a new surprise. Every single thing we opened had something inside we hadn't really thought about. Or sometimes when you cut something you're intimately familiar with at a funny angle, you find something you're not familiar with. And it was really, really hard to choose which angles to show of things and which subjects to include, because there was just so much. We could have made the book 3 times as long. Not that that's necessarily an advantage, but it was just one thing after another. And maybe that itself is the surprising thing.
That it didn't get boring. That it didn't you didn't tire of the surprise, or that it didn't stop being surprising.
Well, we cut into a whole lot of things that we hadn't cut into before. And I'm not sure I can... let me actually, one example. We have a circuit board from a smartphone that we cut at a steep angle, not just a cut through it, but it is like a 15-degree angle through it, maybe 20-degree angle,
Oh, that was
Yeah.
one of my favorites.
So it's like a ramp, right?
like a ramp. And you think, okay, so what? Big deal. But because it's cut that way, you can see each of the layers of copper sitting above the one below it and extending sideways. And you get sort of a isometric view through the circuit board, seeing this such three-dimensional nature. And you see a via there as a circle
Yeah. Yeah.
suspended in space. And it really hammers home that this is a three-dimensional thing. It's a view that all of us are used to in the CAD software when you rotate it, maybe, but it's visceral to see it in real life.
Yeah, that's great. It almost kind of reminds me of, I'm looking at it right now. I have it up on my screen, but it kind of reminds me of like if you had a circuit board and then it was like the sun was setting on it, you know, it's like casting a shadow basically.
Hmm.
You know, that kind of is what it feels like to me. But it definitely that any kind of cross section, you get like these really cool views of like how the layers interact. But then when it starts to tip like this and go to an angle, you see even more.
In your book, refer to page 233.
That's right. Yep. That's good call. Yeah, we should call that out probably when we say this stuff. We should have put in like that little tone like they used to do on the
Ah,
records.
Oh, right.
Like, ding. Turn to page 233.
And of course, we can't forget.
That's gonna age
Yeah,
me right
right.
there, guys. You know that is first off, I said record, and you know, but they must still have that, right? I guess
Oh,
now
yeah.
you
I
just
think
turn the
so.
page and the little
I
built-in
think it's
speaker
an app
says
now.
stuff. Yeah. I just search for it, guys. Just Control F.
And of course, we
That's
can't
great.
leave out the cover photo. I think that's a wonderful example of a very complex circuit board that even people who spend all day long designing PC boards typically don't see. You know, you're looking at it from top down, and everything is flattened out, and half the layers are hidden. And
Mhm.
to see it from the side like that, I think is really quite something.
That's great.
That's actually from the same circuit board that we cut at an angle.
Oh, really? Okay. So that one got a lot of top billing on.
It's a 10-layer board. There's a lot to see.
Man. Someone handed me, where was that? I don't even remember who did it, but someone handed me an iPad board, like an unpopulated iPad board, and I got to like take some close looks at it, and just it's unbelievable. I mean, and that was probably 5, 6 years ago. No, probably more than that. Even now, probably 10 years ago. It's probably a 10-year-old iPad board, and it's just like unbelievable what they're doing there. Like every year, it just gets more and more complex. It's pretty
Yeah,
crazy.
it's not quite as more complex as you might think. PCB technology, although it definitely gets more advanced, it doesn't
Mm-hmm.
get that much more advanced. So, you know,
Mm-hmm.
you're going to use HDI, which is high density interconnect, and
Mm-hmm.
you know they can improve how close together the lines can get, and you know trace widths and all of that. But you know, it's not really the huge leaps and bounds improvements that you might suspect. But you will see interesting innovations in packaging, like this particular cross section on the cover. I really like the fact that you can see this system and package that's soldered to the board, and then inside that, it's got several chips that are stacked with other tinier PCBs in
Mm-hmm.
there. And
Yeah.
then I think there's a POP RAM, which stands for package on package. And it just looks really quite stunning when you realize that this thing has so many layers. It's a three-dimensional structure.
Yeah. Yeah. No, that's really cool. I I was thinking as I asked you guys what was surprising. I remember a component where I forget. I think the top might have popped off of it. Maybe someone had etched it down, but like it was one of those like USB isolator chips. And I remember like looking inside it, and it was the toroidal kind. And so it was like, oh yeah, it's like there's like little transformers in there, and they're just like coupling. It was like just coupling between the two across a barrier interface. I'm like, oh yeah, that's how that works. That makes sense. It's like, it's like but like so much is hidden by the polyimide outside, like that is just like, you don't think about it. And then now we get some views inside. So that's pretty cool. What, you had a bunch of stuff around BGAs as well. Did you think about doing any like kind of, CAT scan stuff, not CAT scan, CT scan style things? I mean, or did you want to have it all just stay physical?
It was a really interesting question. We thought about early on maybe doing some microscope photos, maybe doing some other things. We do have friends who can grant us access to 3D X-rays and other types of tomography, but There's something very visceral and very real about having these pictures that they're not the computer models and they're not reconstructed models. They really look like you could just look at this if you had a magnifying glass and see this. And we tried to keep that aesthetic throughout. I'm not sure that's necessarily the best thing to do. It may be more informative to show other technologies, but I do certainly like it from an aesthetic perspective that we have this consistency.
One of the things that really strikes me is that the X-ray CTs and all that, they can look really amazing, especially if you have kind of that technical background, and so you kind of know what you're looking at. At the same time, it's monochrome, and for a lot of people, it's color is something that's just really interesting and attractive to look at. And so that's one of the reasons I think why we tried to stick with colorful components. And I think we went and seeked out many of those on purpose, just because they really popped and looked really good in the photo.
Yeah, that's a good point. Yeah, it does. It does definitely it helps offset things, and silicon kind of gets that rainbow sheen sometimes, but you gotta get lucky, and that kind of if you're doing photons instead of electrons or
Right.
whatever you're shooting through the board or reflecting off the board, that sort of thing. What's next for you guys? I mean, is there other books?
Not in the near future.
Yeah, I would say that I I'm gonna need a while longer to forget the trauma of the first book before I consider making another book.
Okay, let's hear it here though. So what is it about books that makes it tough? Because I feel like many of the people in the audience, myself included, are I could write a book someday. So what is the slog part of a book?
There's a few different slogs. We did essentially the core photography, cross section cutting, and writing in a 9-month stretch. It was interrupted by we actually took a year off when the pandemic hit. We just sort of set the book project aside and worked on other
Yeah,
things.
yeah.
But we came back to it, and the total amount of time we spent on it was really about 9 months. But they were 9 months of it being effectively a part time job to work on it. And then we had essentially a 1 year editing process.
Oh my. Yeah.
We had a very, very good editor assigned to us by No Starch Press, and I thank them profusely for putting the resources into the book to make it come out really well. But, he would ask the question, okay, what does that mean? And it would be something like, but you know what that means, right? No, he doesn't know what that means. We
Mhm.
use all kinds of jargon constantly that we don't even think about because we're so used to it. And he really forced us.
Do you have an example that like kind of made you realize this, aside from your editor saying as much?
Ah, Eric, can you think of a good one?
We had a long discussion about multiplexing in one
Oh,
spot, and it got really complicated, and we realized that there's just some of that stuff is so hard to describe, and it just took attempt after attempt. The other thing to realize is that we're not trying to write a textbook. We're
right,
trying to write
right.
something that's accessible to a really broad audience. And so it's good to provide some detail, but because there's a limited amount of space, there's just only so much that you can explain. And then on top of that,
Right,
you can't use all that jargon. It's just not going to be understandable. It's going to put people off in many cases.
right.
And then at the same time, you can try to simplify things, but you can't put something down that's technically incorrect. So it also has to be correct too. And so all those constraints acting it together made that text really, really difficult to write.
Yeah, I always like the experiment that Randall Monroe did with the Upgoer 5. I feel like that's like a perfect thing in like the technical communication thing, where you're like, if you actually limit yourself in words, it has a very certain like stilted feel to it, and he used it to great comedic effect. But you need to define things up front and then keep that in people's brains or remind them about it. And like you said, you're not trying to write words and words and words. So I can imagine that's the brevity is the tough part, one of the tough parts.
So, one of my professors once gave me this wonderful piece of advice. He said, if you really understand something, you can explain it in any interval of time. And I think that's really true, that if you really do understand a subject deeply, you can, to any individual person, explain it to them in, one sentence or a book at varying levels of precision. Not different accuracy, just different
Windell,
precision.
I'm now realizing I don't understand electronics. I think because I don't think I could explain things in a sentence or two.
Well, I'm sure you could. So, for this book, we had not just that challenge of explaining something in this amount of space, but we also have a separate challenge, which is you have to explain it to these wildly varying audiences. It's not just that you have to explain this to a layperson who has done zero electronics. You also have to make this such that the person who designed that component, when they open up this book, they'll kind of nod their head and say, "Yeah, that's simplified, but it's basically right." Okay,
Like designed the actual thing that you're photographing. You're saying,
they're going to look at this book.
man, that's a lot of pressure. I mean, the old stuff at least they're probably retired or yeah, but yeah, you're right. That's really I have not thought about that. There's going to be fan mail and angry mail.
Not much of the latter yet.
That's good. Good. Also, you can just I think if you force people to write a letter in, it'll cut down on stuff. Please write to the following address with a self-addressed envelope, that sort of thing.
Yeah, we'll
That's its
only
own
accept it
natural filter.
typewritten paper, preferably
Yep.
with a Selectric, but
That's right. Yep. That's great. Yeah, so I can imagine that would be something that you'd want to do rarely, but I imagine there's a lot more photos and that sort of thing that you guys could do.
Certainly, the subject matter is not prohibitive, and maybe we'll do a extended edition if there's interest someday.
Yeah.
But a book project is just a huge commitment of resources, and both of us have lots of other things that we work on, so we're not eager to jump back into it.
What else are you guys interested in life and work and tech? What are some of your upcoming projects you're willing to talk about? That is a shortened version of that question.
Well, my day job, I design pen plotters for Evil Mad Scientist, and I've been working on next generation pen plotter hardware for quite some time, and I maintain the software and also do a lot of the community support. So I have a lot going on there, and then I also run a project blog where we occasionally post things these days. We used to post a lot more, but we're so busy with the big projects. And Eric has got all kinds of projects going on.
oh yeah, like you wouldn't believe. People often ask me, how am I able to accomplish so much? And I say, well, I've got about maybe a 10 to 20% success rate. So my secret is just starting a lot of projects.
Yeah. Only publishing the things that you want to talk about
Right.
that
And so
are
that's
going
what
well.
people usually see. And
Yeah.
so then they come up with that assumption. So anyway, I spend probably too much time on Twitter, at least for now. We'll kind of see how that
Oh.
shakes out.
Well, yeah, plotter Twitter is another thing, right? So the pen plotter has
Right.
a hashtag that's fun to follow, but may have to go to plotter Mastodon.
The problem is that's not a portable hashtag. And so the
Oh,
community is kind of realizing, oh, we better not make a branded hashtag this time.
Oh yeah, right, like plotter Plues days or something like that, huh? Like
Hashtag pen plotters, what's going forward.
yeah. Okay,
it
that's good
does.
to
It
know.
just
Good.
doesn't have the same ring to it.
Yeah, and the pen plotter that you work on, Windell, is called
It's called the Axe Drop. I was hoping for a plotter tutor.
plotter tutor, like a teacher. Oh,
Mastodons don't have tweets, they have toots.
oh, really? I didn't know that. I'm a very nascent user of Mastodon.
Ah,
I'm basically a stalker right now, or a lurker, I suppose. Um, I've been a stalker much longer. Uh, yeah, no, that's interesting. That's out there, but yeah, I mean, Eric, obviously, you post on Tube Time a lot as well on Twitter.
Yeah, yeah. So that's kind of turned into a big community of people who are into electronics and retro computing and all kinds of interesting things like that. So I kind of use that as sort of a running lab notebook of things that I'm working on in the home shop.
Could you give us
And
a sampling of recent projects you talked about?
so I've been working on a replica Apple One, and it's been a really interesting challenge because the board I got from a friend, and he built the replica based on photos of a real Apple One,
Oh
and he
wow,
drew it up in Adobe Illustrator.
wow, yeah. Well, it does help that it's a 2-layer board, right? So that's all.
Right, right,
That
exactly.
helps on one in front, but still, that's. I remember hearing about someone that did that like professionally. They would do that. They would use Illustrator for like modern boards, not like tracing out old ones.
Yeah,
It's
he
just
was
like,
telling me
whoa.
that the fab vendor really hated the Gerber files because, of course, he started in
Yeah.
Illustrator and there's a ton of
Uh-huh.
extra geometry and stuff. But
Yeah. Yep.
problem is that there's a couple of mistakes. I mean, it's not perfect. It
Hmm.
looks really good as a display piece, but part of the whole challenge of building it up, besides having a bunch of dead TTL chips to deal with, was the fact that there were actually a couple of connections that were either missing or wrong. And so it was really a big troubleshooting
Come
adventure to
on,
go through. And
Waz.
yeah, I
What are you
know,
doing here, man?
right?
I just, yeah. Can you imagine like, your work getting scrutinized 50 years later? I guess it is. That's pushing 50 years as well, right? I mean, like, and it's just like, yeah, I made that mistake 50 years ago. What are you going to say do about it? I was a kid.
Yeah,
It's like every time somebody talks about the Arduino pin spacing.
Yeah, exactly. It's how it is. Just deal with it.
yeah. There's a whole community of Apple One folks, and they actually have all these mods and improvements, and they're
Really?
all designed to go on the back of the board, so it still looks like an original Apple One.
Uh, how big is that community?
There's quite a few people. There's I think it's Apple Fritter is where you can find most of that activity.
Okay, that's good to know. Good pointers.
So, Eric, you going to make that thing with the variable clock rate?
The variable clock rate. I mean, I could try, but the video circuitry is kind of entangled with the timing of the whole board. The
Yep.
reference, of course, is to the Monster 6502 because it has a limited clock speed. It runs up to about 50 kilohertz, and then it starts to lose its marbles for various
Oh,
reasons.
interesting. Yeah, capacitance in the board and such.
Yeah, exactly. So there's a few computers I've been able to connect it to so far, such as the AIM-65 and, of course, my homebrew computers. But the
Mhm.
big problem is that a lot of those early machines entangled the basic timing cycle with the video generation. And the
Mm.
Apple II is a very famous example of that.
Mm. Yeah, I've never really got into the vintage side of things. I think I'm just a little too late and a little too not knowledgeable. But I did get to go to the Computer History Museum and just kind of like wandering through there. It's just unbelievable seeing like how much people did with so little. You know what I mean? Like that. Of course, you guys know, but like, just the fact that anything worked on those machines is amazing to me.
Yeah, exactly. For me, it's actually a great learning experience because I get exposed to all kinds of interesting design techniques that may not be quite so common anymore. Everyone just stuffs everything in a giant SoC, and all you have to do is just hook up the
Hmm.
wires. But back then, there was a significant design effort that went into getting these things to work properly.
What were some of the challenges there?
A lot of timing challenges. So
Yeah.
back in the day, people didn't use synchronous logic quite as much. What that
Oh.
means is synchronous logic is you've basically got some combinational logic. In other words, just a bunch of gates, the output of which goes into a D flip flop.
Yeah.
And then you have multiple stages of those cascaded. And that's kind of the whole design of things. But back in the day, when you're really limited on the number of gates that you could put into a design, people used asynchronous techniques a lot more, where you have combinational logic going into different inputs on different kinds of latches. So you
Mm.
might have a set reset latch or a JK or something like that, or you might build your own latch out of combinational logic. And so
Mm.
there's all kinds of weird little timing issues that you have to deal with, and it
Yeah.
makes the design incredibly challenging. One of the biggest innovations of HDL-based design is that it kind of solves that for you, because you just simply follow this little strict template, and then you can take advantage of all these analysis tools. And so timing is much easier
Yeah.
with that kind of a modern design paradigm.
Yeah. I always think about the errors I used to get when I was doing FPGA stuff, and it was always like, you didn't make the clock rate, and just kind of visualizing like you didn't, all of your logic didn't get to like this deadline basically where the clocking was based on physics and how far it could get across the chip and that sort of
Yeah,
thing.
exactly. And it's
Yeah.
not complicated. What it does is it looks for the worst case, longest timing delay path in your
Yeah.
logic and says that's your max clock speed. And that's it.
I can imagine that's a nightmare to debug though, because like if you're not making timing in this asynchronous manner, it's just like you're just chasing ghosts all the time. And I'm
Yeah, it
guessing
makes it
this,
very challenging. So
a one or two channel scope was probably not your, it's better than nothing, but it's not easy.
yeah, I would say my most frequently used tool for that is the Sele Logic Pro 16.
Yeah, totally.
And so you get 16 channels, pretty easy to use, and I've used it for debugging all kinds of crazy issues.
Yep, that's awesome. On other retro type computing you've been doing as well? I mean, is there other things you're building there?
All kinds of stuff going on. I dug up a what's called a stringy floppy, which is more of a restoration and investigation project than it is something that I'm designing. But it's basically a miniature tape that was designed as sort of a floppy disk replacement for computers in the late 70s. And it doesn't store very much data, but it has some interesting design principles that made it a very popular choice for a very short couple of years until the prices of the 5.25-inch floppy drives came down to the point where people all switched over. And so it's very old, archaic hardware that has essentially no documentation. And so I've been going in and reverse engineering it to try and figure out how it works.
Yeah, that's cool. That's really cool. I'd never heard of that. You said stringy floppy or just
Stringy floppy.
Stringy floppy. Interesting. Yeah, I mean that is interesting. I mean, like, so you guys are in the core of it, right? You guys are basically like in Silicon Valley, and like we mentioned that a lot of the surplus stores are shutting down, and unfortunately, a lot of the pioneers are aging or have passed away, and it's just like, how do we preserve some of this stuff? You know, both of you have done a lot. Obviously, I mean, you have stuff that you're preserving in print now, but like, and you're doing projects, both of you, that are preserving kind of history and getting people interested in this stuff. But how do we preserve it? And I guess more importantly, should we preserve it? Is it worthwhile to preserve it?
Absolutely. I think a lot of it is getting the word out, getting the stuff documented in places like the Internet Archive and other documentation archives. So not just documentation, but details about the design. So one of the things that is kind of at the front of my mind after recent events on Twitter is I realized that a lot of this documentation that I put together, if it's not something that I've put on GitHub and it's related to a reverse engineering project, it's stuck on Twitter. And the future of Twitter is a little uncertain. And so I want to make sure that all of that information will still be available to people, regardless of that.
You know, Chris, by the time this podcast is released, the situation on Twitter is going to be very different than it is today.
Yeah.
Anyway, I've downloaded my data archives. I hope you have too.
I have.
Absolutely.
Yes. Yep. Yeah. I mean, and it does actually, it's interesting too, you know, so thinking about, you know, early computing and really even early internet, you know, actually like there was no cloud. It was just your own computer and someone else's computer. But like running your own site, your own documentation, anything like that can go away, you know? And so obviously we want to support Internet Archive, and that sort of thing is to stick around. But Twitter, Internet Archive, all of them, it's like you kind of just need to have, at least like you said with GitHub, you know, some people are going to have local repositories, that sort of thing. So it's almost like making sure there's enough information out there, but then also that it's spread out enough and not enough people's computers as backup.
Well, one of the things that's going to happen in times of uncertainty like this, like one of the problems, if Twitter were to go away, their link shortener goes away. And so much stuff that is just, you know, linking from one place to another on the internet that doesn't even involve Twitter really directly is using their link shortener. This is just catastrophic.
Yeah. Yeah, that's like fabric of the internet, basically, at that point, huh?
Link shorteners are kind of a terrible idea.
Well, unless you want to track a link, you know, unless you want to see who's clicking your stuff, then it's great. Commerce and being tied up is part of the problem, I think.
It's just also temporary, and that's I don't know. That's something I come to realize over the last couple of days, looking at alternative platforms and stuff like that. Is, you know, they each have their pros and cons, but it really makes you realize that so much of this stuff that we deal with is really temporary.
That's why we should have a book.
I just print out all the tweets. I like it.
Yeah, there you go. Yeah. Boy, that'd be a lot of a lot of paper and a lot of spam.
A lot of paper.
I don't know. Your tube time archives on Twitter make a pretty good book. Sure you don't want to do another book this year?
There you go. Yeah.
My eventual goal is to turn all of that into a static web page. So I'm hoping with a crappy Python script and the downloaded archive, I could probably pull something together.
That's a great idea.
Anything with an image definitely goes in, that sort of thing. Any replies don't go in. any memes stay out.
I get, you know, honestly, that's the hardest part, is that there are a lot of really good people in the community that comment very frequently on my tweet storms, you know, on particular restoration projects. And I came to realize that really tube time is not just me, but it's it's everybody else who participates.
Yeah.
Because I'll go in and say, hey, I'm working on this thing. And then somebody will reply and say, well, I designed that back in the 80s.
Oh, wow.
And then
really?
I'll go and reply and say, well, I got a bunch of questions for you. And all of that gets somewhat preserved on Twitter. It's a little hard to search for sometimes, but if I can find the thread, and I keep a whole set of bookmarks of some of the projects that I've worked on, then I can just click on that, find their comment, and go, oh, yeah, that's right. They said such and such.
Yeah, we need like an internet archive just for electronics Twitter. That's what we really need.
Yeah, exactly.
Yeah. Yeah, it is tough too. Like, not that, obviously we're here to talk about your book, but because the three of us are denizens of Twitter and, and lamenting its potential downfall, people often ask me like, well, why do you on there? Like last night I was trying to explain some stuff about it to my wife and she's like, well, why don't you just leave? I was like, first off, I'm addicted. Okay. Let's just get that out there. And second off, like it is, it's an ad hoc community. It's asynchronous. Like I don't know, it's open. You don't have to have an invite, like all of those kind of things that like it's the lack of walled garden, right? So like that, those things are all good, and you can kind of peek in on other people's conversations. I can see you as Tube Time talking to the 1980s designer, that sort of thing. I can glean knowledge from that. Like, yeah. So like, I don't know. I just want that style of a thing. It doesn't have to be Twitter, but that kind of like discourse I want in my life, and I want to be able to view it and be part of it,
And that's one of the reasons why I've been looking so seriously at Mastodon, but it does have some big issues. Not necessarily technical issues, although it does. I mean, I'm not really referring to that. It's kind of a cultural issue because the folks that I see on Mastodon are too much like me, right? So they're technical people doing technical things. And one of the biggest appeals of Twitter to me is that it's such a broad audience.
Yeah.
I get all kinds of interesting people looking at my stuff that don't really know what's going on and will ask questions. And so there's sort of this educational aspect to it as well.
Yeah.
You won't believe how many DMs I get from people that are confused about something. And I've found it really rewarding for everyone involved to go in and respond and answer folks' question. I mean, it's great. It's a great interaction. And I think everyone benefits from that. Whereas Mastodon, it has this sort of barrier to entry. Like you kind of have to figure out how it works. And some things are a little confusing, especially if you've never looked into it before. And so I think that's kind of off-putting to a lot of people that have no problem with Twitter or Instagram or some of the other platforms out there.
Yep. Yeah, it is kind of like almost like when you guys had the Monster 6502 at Maker Faire, like the same kind of thing where like people are walking up. They might just be walking by and they might be like, oh, that's cool. Walk on, no problem. But they might be like, no, I'm into this. And like now I want to, they go and take like a Ben Eater course to try and learn more, or scroll back through your tweets to learn more, or just sit there listening as you're explaining it, that sort of thing. Like,
Yeah.
We actually have the Monster 6502 set up and running on our front desk at the office right now. And sometimes people walk by and they're just walking by. We don't have a sidewalk here, but if there were a sidewalk, they'd be walking on that. And we've had people actually stick their head and say, what is that? Just out of nowhere.
Is that Skynet? Because it looks like Skynet. No, no, it's not.
Had somebody say, what is that monitor showing? And that was the funniest one to me because
that's a good one.
Yeah.
That there is the internet, my friend.
That's Yep.
The internet's grandfather right there.
Yep. That's where it all started. Man. Well, let's make sure people know exactly where they can go and buy this beautiful book and so they can scroll through it and marvel at it like I do.
I would recommend that if you'd like to get the book, you go to opencircuitsbook.com, and we have a list of resellers of the book right there. You can get it direct from No Starch Press. My store, Evil Mad Scientist, has signed copies while they last and links to other sources as well.
Great. And where can people find you in the short or long term?
You can find me at evilmadscientist.com, and I hope that's long term.
Yeah, that one is. Well, you as long as you don't miss the domain registration, you'll be fine.
Yep. I mean, I've also got Windell.oskay.net, but that's mostly my leftover pages from the 90s.
Yeah,
my vestigial web presence.
They do stick around, huh?
Uh-huh.
Eric, how about you?
And I've of course have the Twitter account, at least for now. So that's Tube Time US. And I also have a blog, which every once in a while I'll update, and that is tubetime.us. So you can see the relationship.
Yeah,
Anyway, if
definitely.
Twitter's not around, I'm also on Mastodon as tubetime at mastodon.social.
Great.
And I think I have maybe 1 or 2 posts there, maybe more, will be forthcoming. So we'll see how that goes.
Yeah. We'll see how it all goes. Well, guys, thanks so much for coming on and explaining the book today. It's been really, really great to hear about it. Good talking to you both. I hope we get to hang out again in person soon. And I hope people pick it up. I think this is going to be many coffee tables will be adorned with it in many bookshelves. Well, it probably won't sit on the bookshelf. It'll probably be down. This is like a bedside table kind of book, view it before you go to bed and dream of circuit boards and chips and stuff like that.
Dream of circuit boards and chips.
All right. Well, thanks for coming today.
Thanks, Chris.
Well, thank you so much.